Let's take a look at a short review of sections 4.1 and 4.2. And section 4.1 is on linear functions. Linear functions are functions that can be written in the form f of x equals mx plus b. Or y equals mx plus b, which is a familiar form, hopefully, slope-intercept form of a line. Remember, the slope is m and the y-intercept is b. A linear function could be increasing, decreasing, or constant. It's increasing if the line is slanted upward or if the slope is positive. It's decreasing if the line is slanted downward or the slope is negative. And it's constant if the line isn't slanted at all or if it has a slope of 0. And linear functions also come in various forms. So we have slope-intercept form. We also have standard form, or ax plus by equals c. And point-slope form, y minus y1 equals m times the quantity x minus x1. And linear functions also have a constant rate of change, which is the slope of the line. So take a look at this line that's given. If I want to find an equation for it, I'm going to locate a couple of points on the graph that have clear integer coordinates. And so the y-intercept, because it's really easy to tell that it's at -2, I can write this line in slope-intercept form. So I'll say f of x equals mx plus b. Now to get the slope, I can just count the rise over the run on the graph to get from one point to another, or I can use the slope formula. Okay, so as a review, the slope formula, m, is y2 minus y1 over x2 minus x1. Okay, and what you could do is just use these ordered pairs 0, -2, and 3, -1, and plug them in. So the y2 minus y1 is -1 minus -2, and x2 minus x1 is 3 minus 0. And we get +1 over 3, so 1/3. Okay, but on the other hand, if you just looked at the graph and counted the rise over the run, you'd count up one space and over to the right 3 spaces, and so that would be a 1 over 3. So 1/3 x, and then plus b, which is the y-intercept, or -2. So say we wanted to write an equation of a line if a graph is not given. So for number 1, we're given f of 2 is 5 and f of -1 is 6. Okay, this really tells me that I have 2 ordered pairs, 2, 5, and -1, 6. And if I have 2 points, I can find the equation of the line. So the first thing, we'll find the slope. Okay, again, it's y2 minus y1 over x2 minus x1, or 6 minus 5 over -1 minus 2. And that's 1 over -3, or -1/3. The next thing that we'll do is recognize that neither of these points is the y-intercept, so I may choose to use point-slope form instead. Y minus y1 equals m times x minus x1. And we'll just substitute -1/3 for m, 2 for x1, and 5 for y1. And we get y minus 5 is equal to -1/3 times x minus 2. Okay, lastly, we'll distribute. And so we have y minus 5 equals negative 1/3 x plus 2/3. And add 5 to both sides. Okay, and 2/3 plus 5 is 17/3, so I would get negative 1/3 x plus 17/3. Number 2, it says we want to determine an equation of a line perpendicular to the given line that passes through this point, negative 4, 1. We talked about parallel and perpendicular lines in the first unit of the course. And so remember that parallel lines have the same slope and perpendicular lines have slopes that are opposite reciprocals. And so if the given line has a slope of 2, then my new line, the line that I'm trying to write the equation of, has a slope of negative 1/2. And then from there, we're going to use this point and this slope to write the equation. And again, I'll go with point slope form. So y minus 1 is equal to m negative 1/2 times x minus negative 4. But that becomes x plus 4. Next, distribute this negative 1/2. And we get y minus 1 equals negative 1/2 x minus 2, and then lastly add 1 to both sides. And we get the equation y equals negative 1/2 x minus 1. Section 4.2 is on modeling with linear functions. And so one thing that we want to be able to do is determine whether data are linear. Hey, remember that linear functions have a constant rate of change. So if we take a look at this time and balance data that are given, say the balance in your checking account after so many days or weeks, we're going to find the change in balance over change in time. And just use each pair of consecutive points to do this calculation. Now, remember, to find the rate of change between each of these pairs of points, we're really just going to use the slope formula. So y2 minus y1 over x2 minus x1. So in this first case, it's 130 minus 100 over 2 minus 0, or 30 over 2, so 15. And then the next case is 190 minus 130 over 6 minus 2. So this is 60 over 4, or 15. And then lastly, 250 minus 190 over 10 minus 6. Okay, so again, that's 60 over 4, so 15. Because this rate of change is the same every time, we say it's constant, then the function is linear. Well, suppose that a cable company charges $95 for installation and $125 per month for service. We want to write an equation modeling the cost after T months. So we'll say C of T equals, so 95, that's a one-time fee, and the 125 happens again and again. So we'll say 95 plus 125 T is our formula. We're going to complete this table of values. And so the first thing we'll do is plug a 0 in to this function equation. Okay, so my scratch work, I'll just do it down here. C of 0 is 95 plus 125 times 0, but that's just 95. Okay, and then C of 5 would be 95 plus 125 times 5, and that's 720. Okay, and do that one more time. Substitute 10 for T, and we get 1345. So now it says graph the function. So in the coordinate plane, I'm just going to graph 2 points. Okay, so 0, 95, so that is very close to 100. And then pick one of these other points. It doesn't matter. Maybe I pick the 10 and 1345. Okay, and so that would land somewhere in here. And we know that this is the equation of a line just because this is written in f of x equals mx plus b form. And therefore, just sketch a line between those 2 points. And lastly, it says use the function to determine the total cost of 18 months of service. So we're really finding C of 18, because 18 is a t value. And that's 95 plus 125 times 18, or $2,345. And let's take a look at one more example. Suppose the population has been decreasing at a constant rate over the past decade. In 2010, the population was 24,290, and in 2020, it was 22,390. So we want to determine the growth per year. Okay, so it's really the change in population over the change in time. And using these populations, you can write them as ordered pairs, where 2010 could be the year 0. And so 0, 24,290 is one ordered pair, and the other one is 2020 is 10 years later, so 10, 22,390. So 22,390 minus 24,290 divided by 10 minus 0 is negative 190. Okay, so this is really the population is decreasing by 190 people per year. Okay, we want to write an equation for the population where t equals 0 is the year 2010. Okay, so recognizing that what we just found, that change in P over change in T, knowing that this data are linear, it does say the population has been decreasing at a constant rate, so those are some key words, that we just found the slope of the line, and so M is negative 190. We also have the y-intercept of the line, and so B is 24,290. And now we can write this equation in slope-intercept form. So we'll say P of t equals mt plus b, so negative 190t plus 24,290. What if instead we wanted to write an equation for the population where t equals 0 is the year 2005? Hey, the slope is still the same, negative 190. The y-intercept is not the same. So let's figure out what it would be really quickly. Okay, so I'm going to start with the population in 2010, which is 24,290. And in previous years, if this population has been changing by this constant rate even before 2010, so we would have a larger population earlier. And so we're going to add this rate of change, 190, and then multiply by how many years that have passed. And so this would have occurred over a 5-year interval. So we'll say 24,290 plus 190 times 5 is 25,240. That should be the y-intercept. And now here's our equation. P of t is equal to negative 190t plus 25,240. And then last part, it says use your equation to predict the population in 2025. Hey, well, luckily we can use either equation because they both should produce the same population in the year 2025. So I'll start with the last equation that we had found, the PFT, and compare the years 2005 to 2025. And so 20 years have passed. So we really want to calculate P of 20. And that's negative 190 times 20 plus 25,240, or 21,440.